Okay, so we're on to some more examples. We are going to be doing a few examples where we are going to be multiplying by the conjugate. And so you might remember a long time ago with fractions, if you had like 1 over 1 minus root 2, it's improper to have the square root downstairs. So we multiplied by 1 plus root 2 all over 1 plus root 2. And the conjugate is the same expression, but the sign of the other term is flipped so that it will be a difference of squares. So we're going to see that in this example. So we have to show that the cosine of x all over 1 minus sine of x is the same as this right here. Okay, so you might see the conjugate already. We're going to choose the left side. So I'll write that again, cosine of x, 1 minus sine of x. Sorry, I don't need equal signs right there. And now we're going to multiply by the conjugate and just see what that does. Remember, this is legal because if you multiply by 1 plus sine of x on the bottom, it would be affecting the fraction. But if we do it to both the top and bottom, we're actually multiplying by 1. We're multiplying by a fraction with the same thing over itself. So we're not changing anything. We're changing the way it looks. All right, so I'm just going to for now write cosine of x times 1 plus the sine of x. And now downstairs we're going to have a difference of squares. We're going to have 1 minus sine squared. Okay? And in general, this is just what I've learned from doing a few of these. If you want to distribute, it's actually not going to help right now. Often keeping that like this is it's going to help just to leave it the way it is right now, okay? And you'll see why that is in a moment. The next thing I notice is on the bottom I have a sine squared and a 1. So what I'm thinking right away is sine squared plus cosine squared equals 1. Is there a way for me to get 1 minus sine squared? And yes, cosine squared of x is the same as 1 minus sine squared of x if I subtract on both sides sine squared. So this is what we could write on the bottom of the denominator instead of 1 minus sine squared. So cosine of x, 1 minus sine of x, all over cosine squared of x. Okay? So if you're wondering, why don't we distribute? Well, we would have had cosine times 1, cosine times sine, and then we would have had to think about dividing both sides of the top by cosine of x. Because right now, you can see cosine of x is going to cancel with one of the cosine of x's. If we do that, we're going to have 1 minus sine of x, just all over cosine of x, which, I'm sorry, that's a plus in there. Whew. Okay, so that is exactly what we wanted to prove in the very beginning. Okay, so I have one for you guys. I would have you guys try this. It's going to be cotangent squared of x all over 1 plus cosecant of x. It's pretty similar. You have to prove that that's cosecant of x minus 1. So now you should probably stop the movie and give it a try. Okay, now I'm going to take the most complicated side, the left side, and I'm going to do the conjugate. So this is cotangent squared of x all over 1 plus cosecant of x. And I'm going to multiply by 1 minus cosecant of x all over 1 minus cosecant of x. Oof, my handwriting. It's gotten pretty bad there. Cosecant of x. Okay. Now again, on top, it'll be better if we actually just leave it as cotangent squared on top with 1 minus cosecant of x right there. On the bottom, we're going to have 1 minus cosecant squared x. That's that difference of squares that we keep seeing over and over and over. Okay, so we should remember that 1 plus cotangent squared of x is the same as cosecant squared of x. And I'm writing that down right away because I see a 1 and a cosecant squared on the bottom. So we're probably going to have some sort of identity. So here's the tricky part about this one. I'm going to subtract a 1 over, Now the issue is that my signs are flipped. My cosecant is positive here when it should be negative, and my 1 is negative when it should be positive. So negative cotangent squared of x should be with cosecant squared negative and the 1 positive. So that would be 1 minus cosecant squared of x. Okay, so what I'm saying here is that on the bottom of this fraction, I'm going to be replacing that with a negative cotangent squared of x. Okay, and those cotangents, they will cancel out. So really, it's like 1 minus cosecant x all divided by negative 1. And what that does is it flips our signs. So we will have a negative 1 and a positive cosecant. And that is exactly what we wanted to prove.